This is for Year 12 Methods. It's the 2011 Functions Application Tech Allowed question number 5. Government body has constructed a machine to control and monitor the growth of secret antiviral agent, which is produced in the form of gel. The volume in cubic centimetres that fills time t minutes after being put into the machine is this, where t is greater than or equal to 0. Okay, so this is a logarithmic curve. If I was to have a little think about what it looks like, it has an asymptote at -1 and it's been moved up, so I imagine it looks something like it's been moved up 15. It looks something like that, but t has to be greater than or equal to 0. So it has a value there, and then it gets bigger and bigger and bigger and bigger and bigger. Okay. Find the initial volume. So I might define our function over here. So I've got 15 plus 7 natural logarithm. I'm going to use x plus 1 instead of t, and I'm going to use x every time. And I might define that and call it f. Okay, so initially f of 0 equals 15. So its initial is 15 cubic centimetres. What is the exact after 15 minutes? So t will equal 15 after 15 minutes, and I put 15 there. And that's the exact time. 28 log base e of 2 plus 15, and the exact volume. Cool. Find the exact time that it first reaches 17. So what I'm interested then is when f of x equals 17, and if I solve that for x, I get e to the 2/7 minus 1 is the exact time when it's at 17. And roughly that is at around about 33.33 minutes. Okay. So down to part C. There's a fault in the design of the machine, and it is found that the antiviral agent starts to escape when it's occupied 40. When will it start to escape? So I need to solve all of that, but I wish to solve it for when it equals 40. And I get that particular time. And at what time will it be? If I take that answer, it's after 33.56 minutes. And if I take my 0.56, and I get rid of all of that, and I times that by 60, it'll tell me how many seconds that is. And it's 34 seconds. So after 34 minutes and 34 seconds, that's when it'll start to escape. If the volume of the space of the antiviral is kept at 40 or less, the government can still use the machine. Otherwise, a new machine will need to be built. The function gives the volume of this. Okay, so I have a situation where I have a graph. I know it starts at 15, has an exponential curve to it, then it's at 40, and I know when it's at 40 because I worked that out here. It's at 40 at e to the 25 on 7 minus 1. So given that, okay, M1 has to equal e to the 25 on 7 minus 1, because that's when that particular point where I go from my log curve into my constant, which is equal to 40. Then I kick into a linear, and I'm interested in M2 when the linear starts. That will occur when this equation here equals a y value of 40. So if I kick into minus 20x plus 1040 equals 40, and I solve that for x, that tells me at time 50, so I know that's at time 50. So m2 equals 50, m1 equals e to the 25 on 7 minus 1. Using this, find out the volume, when will it equal 0? It will equal 0 when this linear gets down to 0. So I take this answer and I make it equal to 0, and then I solve for x, it tells me it's at 52. So that's okay, so I'll get down to 0 at time 52. Okay, the government says I now have this. Find the exact range of the values of k such that the volume of the space occupied by it stays above 20. Okay, this is a logarithm that has some sort of move to it. So let's have a little exploration of what the logarithm might look like. Okay. Normally, depending upon what 2k was, I'm going to have some sort of asymptote, and that asymptote will be at t equals minus 2k. And this is going to look like that. Some logarithm's been moved up 15 points. It has to have this 20 or greater. Now, it must have some sort of sideways translation so that we can guarantee that that is 20 or greater. For it to be a positive logarithm, it's going to have this shape to it. Therefore, the y-intercept has to be 20 or greater. Now just check the wording here. Is it above? Stays above. So the y-intercept has to be greater than 20. And the y-intercept will happen when t equals 0. So I'm going to have 15 plus natural logarithm of, I'm going to call it 0 plus 2k. And that has to be greater than 20. Interactive, advanced solve for k. Okay, k's got to be greater than e to the 5 divided by 2.